Evet arkadaşlar. So this is my data. It has 2 hertz. Okay. It's a 2 hertz sine wave. Now I am going to start like FA is equal to FFT of A. If I do it like that, how many numbers will I get arkadaşlar? If I do it like this, how many numbers will I get?
Length of the signal.
With the same with the length of the signal, which is 1001. Bakın. If A is 1001 complex numbers. Why are these complex numbers? Neden bunlar kompleks arkadaşlar? Why are these numbers complex?
In FFT we have J, I.
We have real part and imaginary part. That's why one part is like related to sine, one part is related to cosine, right? So in terms of like this one is related to the cosine part of our Fourier transform. This part is related to the sine part of my Fourier transform. Okay. So here, when I do FFT like this, it really doesn't give me the frequency components that I want the details from. If I write it like that, 100, then it will calculate 100 numbers. Anladık değil mi arkadaşlar? So if I don't write anything like this, it will give me such coefficients, complex coefficients, that it will have many numbers. Okay. For example, if I do it like that, if I plot the FA, what kind of a thing will I get? Such an interesting plot, which doesn't mean anything. Okay, so that's why, because it's a complex number, I should do this absolute value of A, and I will have such a graph. Anlıyor muyuz arkadaşlar? Do you understand this graph? It has one peak here, one peak here. How many numbers do I have here? 1001. Maximum number is 1001. But I don't have any frequency. What does this 200 mean in terms of frequency? Because you're going to do alpha, beta, delta, theta, gamma stuff, right? How are you going to find out the power of alpha, total power, average power of alpha? So you need to know for each number corresponding to which frequency value. Okay, why is there such two peaks even though I have only one 2 hertz sine wave?
It's a two-sided spectrum.
It's a two-sided spectrum. What do you mean by that, Ahmet Faruk?
One of them is in negative 2 hertz and the other one is at 2 hertz.
2 hertz. But there is no negative 2 hertz, right?
Yeah.
There is no negative 2 hertz. So why do I have it as a 2 hertz like that?
Because Fourier has a negative axis as well, like minus axis.
Minus axis. Okay. Arkadaşlar, this is totally how this FFT works. Okay. So it doesn't, it really doesn't mean in terms of like physical thing. It has an algorithm. It calculates the coefficients. Okay, it calculates the coefficients. First, the things that we want, and its mirror image in the second part. Okay, Like if you check the FFT algorithm, can you see that arkadaşlar? Yes. So if you check the FFT algorithm, bakın x0, x2, x3, x4, x6 are calculated n over 2 point DFT. Actually, what we like, even part and odd part of our signal is in this algorithm, in this Fourier transform algorithm. Let me show this, for example, with reverse. What I'm trying to say is this this stuff that you see, this thing that you see here, this part is redundant for us, okay? It doesn't mean anything. The second half, it comes from the algorithm of FFT. FFT is designed to speed up the calculation of Fourier transform. And I am mainly interested in the first half of my FFT values. Anlıyor muyuz burayı arkadaşlar? It is a matter of algorithm. It works fast and it gives us such a thing. That's why I need to go. How many numbers do I have here? 1001. I should go and plot one from this is my actual plot arkadaşlar. So half of it. Bakın ne yaptım? My number was 1001. Okay, I will divide it by 2, almost 500. I will start from 1 and go up to 501. If I do it like this, if I do it like this, 101, how many numbers will I get? 101 numbers. Now, what should I write here arkadaşlar?
50.
51. Yani if I have 101, okay, why 101? One is the first one corresponds to zero frequency. Okay? Yani şöyle bir şey açayım. Şu en baştan bir size şurada bir açıklama yapayım. Can you see my PowerPoint slides arkadaşlar? Yes. Let me try to tell you here. I have, let's say pardon. Arkadaşlar, I have numbers, okay? I have numbers here, my EEG data. Let's say I have, let's say 1000 points, okay? If I use FFT, and this is a signal, if I use FFT directly, I will get 1000 complex numbers. Okay? If I do FFT A, 100, I will get 100 complex numbers. Why do I change this? Why do I need to do such a thing? Bakın, şundan dolayı. What does this mean, FFT A of 100? I will calculate coefficients, Fourier transform coefficients at 100 points between regularly spaced 100 points, actually 100 frequency points between 0 hertz up to Fs over 2 hertz. Fs being sampling frequency. Burası anlaşıldı mı arkadaşlar? 100 regularly spaced, that means I have numbers like, this is a time domain signal, right? This is a time domain signal. Now I'm going to convert it to a frequency domain signal. And finally, I will have a value at 0, a value at another frequency point, so that I will have this many, let's say, n number. This is 1, 2, and n frequency points. Okay. What is this last value? Fs over 2. For example, in your EEG data, your Fs is 128 Hertz, right? Arkadaşlar sizi göremediğim için şey yapamıyorum. Ama benle beraber misiniz?
Yes,
Takip ediyor musunuz?
Buradayız hocam. Evet.
So what is this Fs over 2? 64, right? So I will have 0, 1, 2, all these numbers, but this will be DC, and this will be 64 Hertz. If you remember from yesterday's discussions, we said that we can only sample frequency values up to half of my sampling frequency. Do you remember this? Omega S should be greater than or equal to 2 omega n, right? We discussed this, the omega max. So our sampling frequency is 128 Hertz, like half is 64 Hertz. So I can only sample up to 64 Hertz. But between 0 and 64 Hertz, how many data points, how many frequency points I will calculate depends on my choice of this number. If I write 100 here, I will have 100 such numbers. There is no, so this will not be 0. This is 0 Hertz. This is Fs over 2 Hertz. But this will be my first frequency value, second frequency value, third frequency value. The first frequency value will correspond to 0 Hertz. How about this one? If I have 100 numbers, arkadaşlar. If I have 100 such points between 0 and 64 Hertz. What is this second data point in my frequency domain? In my frequency domain, the second point, at which frequency value will I calculate my FFT coefficient?
1.28.
0.64.
Nasıl yapıyoruz? Bakın, if this was like, I have this, and this. Let's say this is 0. This is maximum 3 Hertz. What is my spacing here? Benim dersim var, bir saatte bitiyor. Bir saatte bitiyor. Şimdi what is this interval between F's arkadaşlar? 1, 2, right? How did I do it? 3 minus 0. 3 minus 0. How many points I have? 1, 2, 3, 4. Divided by n minus 1. How many numbers I have? Minus 1 will give me a delta F of 1 Hertz. Delta F means I will calculate my coefficients at 0, 1, 2, and 3 Hertz. What happens if I have 0 to 64 hertz? And if I want 1 hertz, 2 hertz, 3 hertz, 4 hertz stuff, what should be delta F? 1 hertz, 2 hertz, 3 hertz, 4 hertz. Arkadaşlar, what is delta F? Yani change in F.
1.
1 hertz, right? So I'm going to come here 1 hertz. How many numbers should I have here? If I want to have 0, 1, 2, 3, how many numbers, how many such points I should calculate my F value?
65.
65, right? So if I say 64 minus 0 divided by n minus 1 is equal to 1, which means 64 is equal to n minus 1, which n means 65. So if I want 1 hertz interval between frequency calculations, arkadaşlar burayı anladık mı acaba? Anladık mı burayı? So it all depends on what frequency resolution you want in your calculations. Anlıyor muyuz? So if I want, for example, let's come back to the PowerPoint. If I want a delta F of 0.5 hertz, delta F being equal to 0.5 hertz, how many numbers should I calculate my FFT over? Now I have 0, 0.5, 0 hertz, 0.5 hertz, 1 hertz, going like that, and my final value is 64 hertz. What is my delta F? 0.5. What will I do? 64 minus 0 divided by n minus 1, which is equal to 0.5. So n minus 1 is equal to 64 divided by 0.5, which is 128, and is equal to 129. So if I want 0.5 resolution in my FFT, then I need to write FFT of a comma 129. The first one is the DC, 0 hertz. The last value corresponds to half of my sampling frequency. Evet, anladık mı arkadaşlar burayı? Anlıyor muyuz? So,
Hocam,
if I, efendim,
should we take out the DC value from the FFT?
no.
Yeah.
If I want to show it, for example, I'm going to do it right now. What was my sampling frequency? 100, right? 100. If I do 51, sorry, if I write 51 here, what is my resolution? What is my resolution if I calculate for 100 hertz signal, if I calculate my coefficients at 51 points?
1 over
1.
2?
1 over 2, right?
Yeah.
Is that correct? Or 1? Which one? 1 over 2 or 1?
1.
1, right? 1. Bakın tekrar dönelim slide PowerPoint'e. So I have 0 and finally 100, right? 100 divided by 2. My sampling frequency is 100. Sampling frequency divided by 2 is 50. So how many numbers do I have between 0 and 50 hertz? 51. So what is the difference between two frequency values?
1.
1, right? 1, 2, 3, 4 hertz. This part is 4 hertz, 0 hertz up to 50 hertz. Anlaşıldı mı arkadaşlar burası? Yani burayı anlamanız çok kritik. Eğer anlamazsanız ne olduğunu bilemeyeceksiniz. Bir diğer trik, ya buraya 51 yazarsam yalnız bir diğer hatamız olur. If I write 51 here, how many, bakın bir de ne vardı? Sizi yanlışla yönlendirmeyeyim bir saniye. Şimdi nasıldı arkadaşlar? If I write like if I write FFT of a like 100, what do I have? Totally 100 points, 1 to 100. What did I say? Only half corresponds to my frequency values. Only half. That means if I say like 51, then this first one will correspond to, bakın burayı 101 yaparsam ne olacak? There will be between 1 and 51, there will be how many points? This is 0 hertz. This is 50 hertz. And the difference between my points will be 1 hertz. Anlıyor muyuz? Yani ne demek istiyorum? Şunu demek istiyorum arkadaşlar. If I write 51 here, what will I see? Plot absolute value of FA. I will see this. Right? I will see this. So what is that I am interested in? Half of it. So the first half. So actually, I don't have 51, but 25 in this case. For me to have 1 hertz difference, I need to do 101. Okay? Then if I plot this, I will see this graph. Now I will be interested in half of it, 1 to 51. Okay, this is 0, like 1 is my DC, 51 is my Fs over 2. But how should I plot it? 0 to 50. Now I have my correct FFT. DC at 2 hertz, I have my peak sine wave, and maximum is 50. Anlaşıldı mı arkadaşlar?
Hocam 50 is frequency range, right?
50 is my frequency range. My frequency range is between 0 and 50. How about your EEG data? Bakın şimdi onun bir pratiğini yapalım. Buraya 128 yazalım. Okay? Now I have my Fs equals 128. And I have my sine wave. Let's say, hadi alfa dalgası yapalım. 10 Hz yapalım. This is my alpha wave, 10 Hz. Okay. Takip ediyor muyuz arkadaşlar? Şimdi ne yapmaya çalışıyorum? I want to see the frequency components. I want to see the frequency components between 0 and 64 Hz. 0 and 64 hertz. But FFT gives me two of this chunk, like 0 to 64 and another one with an mirror image, which I don't want. But I have to do calculations on them too, right arkadaşlar? And o yüzden if I'm interested in with an FS of 128, I should say FA is equal to FFT of A, 129. And if I put absolute value here, now I will have FA values 129. But I'm interested in the first half for plotting from 0 to 64 hertz. I need FA, half of my FA. Ama half'ı 129 değil de 128'in yarısı yapıyorum. So 64, 65. Now here is my FFT between 0 and 64 hertz. Okay?
Hocam, can I ask something?
Sure. Why do I put this one arkadaşlar 0 to 64? Why do I put 0 to 64?
Our frequency range 0 to 64.
But if, for example, let's say if I would have not 128 but 257, how many numbers I have? 257. Then I would plot 129, but this time I should have 0.5 increments. But again, correct. 10 hertz. Again, correct. Why is it now 0.5 increments?
Should be same length.
It should have the same length. Bakın burada I have 128, 29 numbers, which means bu sefer ne yaptım? This time I have from 0 to 64 hertz, I have 129 points. What does it mean? 64 divided by 129 minus 1, which is 0.5 difference. So I will have 0.5, 1, 1.5, 2, and so on. So that I will have first frequency, second frequency, third, fourth, fifth, and so on. This will be 129. But for FFT, I will write like twice of 128, like twice of 128 plus 1 for the DC value. What should I do for 0.25 increments, arkadaşlar? If I want 0, 0.25, 0.5, 75, 1, and so on. What should I do here? What should I write here?
I will multiply by 4 and
Now
plus
this
1.
will be multiplied by 4, right? 1 over delta F. Yani bakın o zaman ne yapıyorum? Fs times 1 over delta F plus 1. This is my frequency resolution that I want to use in my calculations. This is already given, I know it. It's 128 for EEG, for another 500 hertz, for another 1 gigahertz. But for FFT calculations, I need to use this resolution-based decisions. Evet arkadaşlar, anladık mı acaba? Şimdi
Hocam.
bana
Yes hocam.
Şimdi bana chatten Emre'cim sorunu alacağım. I want you to write a piece of code by which it doesn't have to be written in Matlab. I want you to write it in chat. I want you to use your EEG data. Your EEG data is A. And I want you to write a code to plot frequencies like FFT for 0, 0.1 hertz, 0.2 hertz, 0.3 hertz, up to 64 hertz. Then first do this and I will give you another task just after this. Write chat privately to me. Write a code in chat, please.
Hocam, could you repeat again?
I want you to write a Matlab code in chat by which you are going to plot your FFT with 0.1 resolution. That means 0 hertz, 0.1 hertz, 0.2 hertz, 0.3 hertz. Okay, you got me, guys? Thank you, Nurefshan. Mustafa, thank you. Are you sure, Nurefshan, like you're gonna use, like, will it give you the whole thing or half of it? Like, will this code for example, if you say FA is equal to absolute value of FA is equal to absolute value of A, FFT of A, comma, what should I write here?
The samples number.
Fs times
1 over delta.
1 over df.
Plus 1.
df is equal to 0.1 plus 1. Right?
Mm-hmm.
This will give me how many numbers? 1 numbers.
Yeah.
But I need half of this arkadaşlar for the plot. Değil mi? Çünkü ne yapacak bu? I need half of this. Only this part. I don't need this part. So in this case, for 1281 numbers, I will have both, let's say, this part and this part. But I need only the first part of this signal. So what should I do for plotting? Plot 0, 2 with delta F increments 64, comma, FA 1, 2, half of this without 1, half of this plus 1.
641.
641. Anlaşıldı mı arkadaşlar acaba? So if you put directly this one, then you're gonna have this, the whole mirror image stuff. I am only interested in the first half of it. That's why I first do the FFT with 1281 points, then choose half, the first half, including the 0 plus 640.
But hocam,
yes.
When we do the plot like that, from 0 to 64 with df increments, isn't it have the 1020 to 200?
0, 0.1, 0.2, and so on. 64 divided by 640 minus 1 will give me 0.1 frequency resolution. And there will be 641 points also here. You can check that in Matlab.
Okay.
Because the increment is 0.1, 0, 0.1, 0.2, 0.3, 1, 1.1, 1.2, 1.3. There are 641 points. For example, between 0 and 1, how many points? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? 10 numbers here, plus this one, 11. So I hope you got the main idea. For example, if now I would like to find out alpha wave average power, how should I do it? Kolay olan ne olurdu? I would do it like with not this resolution. I don't need that much resolution. I would need only df being equal to 1. So I would write FFT of A, comma, 128 times 1 plus 1. I would take the absolute value and find my FFT of A. Now, how many points do I have? 129. Right? Then I will need half of it. Now I have everything between 0 hertz and 64 hertz with 1 increment. Değil mi? Şimdi I want you to find out alpha power. Total alpha power. How do you do it?
Only take the alpha range of the frequency range.
What was the alpha range, Emre?
7 and 13.
Hocam 7 to 13.
9, 10, 11, 12, for example. Okay? 13, I may include or not because it may also be in the gamma range, but I don't care. I may include it like that. What is this 7 hertz component in FFA? FFA of 8, isn't it 7 hertz?
Yes.
The 0 is the first component. 1 is the second component. 3, 4, 5. So this is going to be 8, 9, 10, 11, 12, 13, 14. If I do sum FFA between 8 to 14, won't I obtain the alpha power?
Yes hocam, it will be.
Değil mi? Ne oldu? If I take mean, I will find alpha power average. Takip ediyor muyuz gençler?
Yes hocam.
Tamam mı?
Yes, hocam.
Yani if it is beta, then I will go from, let's say, FFA of 15 to 31. Because 30 is like, 31 is 30 hertz. This is 14 hertz. Between 14 hertz to up to 30 hertz will give me the average beta power, and so on. Anlıyor muyuz arkadaşlar? Was it
Yes,
useful?
Yes.
Yes, hocam. Actually, we have done this thing with using filters, and it can give me another result, I guess. It is different.
There are 2 different approaches. This one is much easier as far as I understand.
Yes, hocam. This is easier, I guess.
Hocam, Matlab also has a built-in function to calculate band power.
Yes, that's true. Alpha band power, beta band power, right? But if you use that function, you don't understand these details. That's what I experience. If you say alpha band power, if I do a trick, you might have hard time to find the answer. So please try to understand this logic of FFT. When I was a student, I didn't understand it. Now I want you to understand. Please try to go in those terms. Şimdi bakıyorum. FFT. There are different FFT implementations on the web. You can see dividing by something or those kind of things. We don't care really dividing by something. Just try to understand what FFT does and how do you handle the frequency part. If you don't understand handling the frequency part, you cannot do any calculations, any FFT plots or something like that. Arkadaşlar anlaşıldı mı acaba? Faydası oldu mu bilemedim projenize. Yani this is very critical for you. Bakın mesela Muhammed Zübeyir'in yazdığına bakıyorum. EEG data.mat plot FFT 1000 take ama nerede bir hata var Muhammed Zübeyir? Bu sefer evet doğru tamam. Şeyde bir hatan var değil mi? Frequency resolution'unda bir hata var. Mesela bakın bir Muhammed Zübeyir'in yazdığı kodu herkesle paylaşıyorum şimdi. So this part is correct. This part is correct. Load part is okay. Plotting is okay. Finding the FA, the Fourier transform coefficients is okay.
It should be like that. I wrote it wrong.
This is what Muhammed Zübeyir wrote. Is this correct? Like he said in this part, there should be one column 641. Is there any other mistake here?
For the 0 to 64, it should be 0.y increments.
Yes, that is very critical arkadaşlar. If you do this, you won't be able to plot it because the dimension of your frequency, dimension of your coefficients should match. In this case, it doesn't match. They don't match. Anlıyor muyuz arkadaşlar? Yani şöyle olacaktı. Zero to 0.1 with 0.1 increments to 64. Okay? Hatta hala yanlış. Ben şey yapamadım, özür dilerim. Şimdi tam doğrusunu yazacağım. Biraz evvel Muhammed Zübeyir'in de uyardığı gibi. Ne oldu? F'yi hesapladığım F'in I will take half of the calculated FA because I'm not interested in the mirror image part, only the first part. And in terms of the frequency, I should go from 0, 0.1, 0.2 and so on. Bir diğer tricky nokta, I should be aware of which frequencies are corresponding to which components. For example, in this case, hadi bakalım bununla bitireceğim dersi. In this case, 0.1 increment, how would you calculate alpha band power?
Multiplying by 10 and adding 1, isn't it?
Multiplying by 10, adding 1. Yani, so what do you mean, Yasir? If it is the second point, what does it correspond to if it is the second point in the array?
It should be 2 times 10 plus 1.
So now I have 0, 0.1. So this is my first value, second value, third value. What I'm interested in, 7 hertz. What is 7 hertz doing? You say I will multiply this by 10 and add 1. So this will be 71. Değil mi? O zaman alpha band power from 71 to 131 FA of 71 to 131. Yani which index corresponds to which frequency, you should think about that once more. If it is only 1 hertz increments, it is easy. Just add 1. But if you are doing like 7 hertz, 7.5 hertz, 8 hertz, 8.5 hertz, you have to think like 7 times 2 plus 1. That means 15th index is going to be corresponding to 7 hertz. Anlıyor muyuz arkadaşlar? O zaman da ne olacak? Index çarpı 1 over delta F plus 1. Index is, sorry, like my frequency value F times 1 over F is going to give me the index of my frequency. Yani if I'm interested in 7 hertz, and if I have 0.5 hertz increments or resolution, then I will have 15 as my index. Yani in this FFA matrix or vector, my 15th value corresponds to 7 hertz. My 16th value corresponds to, Kürşat?
7.5.
7.5. 17, 8.
8.
Okay? 18, 8.5. Evet, bayağı heyecanlı bir gündü. Benim de tansiyonum arttı. İnşallah faydalı olmuştur diye ümit ediyorum. Anlayamayanlar için kaydı tekrar paylaşacağım. Şimdi tekrar üzerinden geçebilirsiniz ama not aldınız diye düşünüyorum. I hope you're gonna benefit from this, okay? Evet, görüşmek üzere arkadaşlar. See you on Tuesday.
See you hocam.
See you hocam.
See you hocam.
Questions? I have some time. If you have any questions, an extra question, okay?
Hocam, can I ask something?
Sure.
Hocam, FFT is like discrete time Fourier transform, right?
Discrete Fourier transform, yes.
So we are analyzing we want to analyze a continuous time signal in digital environment.
Does
it make any difference? How?
Because the data that we have already are sampled, right, Mustafa? For EEG
Yes,
data
hocam.
that we are collecting is already sampled. That's why it's a discrete signal or digital signal. Like in terms of discrete, we have discrete points that are taken at certain time instance. 0 saniye, second, 1 over 28 saniye, second, 2 over 28 second, 3 over 28 second. So we really have discrete values. That's why using discrete Fourier transform is appropriate for this.
Okay, then if we had if we wanted to analyze a continuous signal in digital environment, what should we do?
It is not possible, Mustafa. So we still have to convert it from continuous to discrete.
Okay, hocam.
Okay. So
Thanks.
in digital world, we cannot do anything in continuous. We have to convert everything into digital world.
Yeah, but if like when we are plotting a sinusoidal, for example, if we increase the sampling rate, it should be like continuous signal, right?
Yes, yes. It will resemble to being continuous, but it is not. It is still not, right? It is still a sample. Like a video, is it continuous? No. But if I shoot it with high frame rates, it looks like it's a continuous activity. But it is not really. Everything we do in computers, we need to do everything in discrete time.
Yeah. Okay, hocam.
Ama we do some pre-processing and some other things in continuous time, convert everything into discrete time, do our job in discrete time, and we may also convert them back to continuous time and then plot them on an oscilloscope or something like that, or I can drive another machine or something like that and need to convert from digital to analog also. Okay.
Peki hocam.
Evet arkadaşlar, see you. Hope to see you on Tuesday. Have a nice week and weekend.